All right, well, welcome everybody. This is a fun presentation that we're going to be doing today. This is one that I'm particularly excited for because I've been putting a year of my life into researching time series, and actually probably a lot longer than that because I've been, practicing with companies in industry time series analysis for the better part of a decade. But this is one where I've really, in order to be able to teach something, you obviously have to research it. Plus, things are changing so rapidly. And this is going to be a really interesting talk for everyone involved. And I'm just excited to do it. I want to share with you what I've learned over the past year and also share with you a new course that I've just released called High Performance Time Series Forecasting. We'll talk more about that at the end. David, I don't actually have an introduction slide, so you just want to intro yourself and I'll intro myself.
Oh, sure. My name is David Curry. I'm the owner of Sure Optimize, a marketing and data analytics company. And I typically do learning labs with Matt. Some of you guys might be familiar with the learning labs. This will be a little bit different from that, but we're working together to bring you guys some data science topics every couple of weeks. And I'm excited to be here.
Right. Thanks, David. And my name is Matt Dancho. I'm the founder of Business Science. It's an educational platform that allows you to take data science courses that are focused on business. And what the objective is to help you accelerate your career by making this transition into data science. So with that said, we'll get started here. The agenda for today. This is what we're going to be covering in this webinar. Obviously, we're focused here on time series forecasting, but what I want to do is I really want to paint the picture for you for what's going on out there in industry right now. We'll first talk about the big change, which is what businesses are now facing. They are changing, and this is challenging us. So I want to give you some of the information as to what I'm seeing. Next, what we'll do is we'll talk about the three properties of forecasting systems, and in specific, focusing on high performance forecasting at scale. And this involves automation. So we're going to be talking about that. Then what we're going to be doing is moving on to the year of research that I put into understanding time series and investigating all of the different techniques that are being used out there. So we're going to be talking about some of the competitions that I reviewed. We're also going to be talking about some of the software that I actually built over the past year to help improve and be able to do time series forecasting at scale much easier. So once we do those three, that'll be the main topics. And then what we're going to be doing is shifting gears. I'm going to be talking about the pathway to high performance forecasting systems. And I'm going to be giving away to everyone that's on this webinar today, I'm going to be giving away a super valuable cheat sheet. And I'm going to explain, what that cheat sheet contains, and you're going to get it as a bonus. And then at the end, what I'm going to do is talk about my new course, my high performance time series forecasting course, which implements all of the information that we're talking about today. So let's get started. All right. So I want to, since we're in 2020 and actually 2020 is already almost over, I want to talk about the job description for a data scientist. And this is the big change that I'm seeing in organizations is we're now being asked to do a lot more. So businesses are shifting. They're changing. They're wanting more automation. They're wanting time series forecasting, and they're wanting it at massive scale. And this is because these data sets that they're now with customer data and with product data and with timestamps and being able to track, when orders are being placed, when stock outages are happening, when, just when things are occurring by timestamp, we now have these huge, massive databases of time series data. And we can utilize that and we can really be able to help the business out, but it requires a new set of skills, and it requires, in order to be able to meet what the businesses want, it requires a lot of transformation in our own skill sets. So what they want is automation, time series forecasting at massive scale, and that's what we need to be able to give them. So your organization, your boss calls you into the office or pulls together the data science team, or maybe it's the director or the VP, and they're saying, hey, we've got all this data that we have available to us. Why can we not provide the business faster forecasts, more frequently, more granular at the product level, and really just be able to do this on a massive amount of data on a high frequency? So something they might say is, I need a data scientist that knows time series, can improve forecasting, and I need it done for 10,000 time series every day. That's a mouthful. That's a lot of work. So, that's something that is not, though, that's not out of the ordinary now because of these massive data sets and because of the needs of the business. They want to be able to understand what's happening at a more granular level. So what are they asking for when they say that? I need 10,000 time series forecasts every day. What they really meant to say is, I want you to make a high performance forecasting system. Basically making a system that produces forecasts, at some time frequency into the future. And I want you to do it a lot of times for a massive database. So basically doing this 10,000 times is what they're asking for. And they want that information so that way they can provide it to the business and they can be able to make better decisions, understanding when stock outages are going to occur, understanding what the demand is going to be for a product, understanding how much material to purchase for the next, 3 to 6 weeks. These are all questions that the business is trying to answer. So this is changing and challenging us. So to meet today's demands, what companies are now requiring, we're having to shift from what we've learned in school to adopt some new strategies and some new technologies in order to be able to meet these demands. So let me kind of take a few steps back. So I want to talk about 5 years ago, what was happening and what I was doing in businesses. So in 2015, what I was doing was I was forecasting product data, and I wanted to know what sales revenue and how many units would be sold over the next quarter. And I might try and do that kind of at a pretty high level and at a frequency of, say, a monthly frequency. So every month I wanted to be able to predict maybe the next 2 or 3 months in advance what the demand is going to be for some high level product category. And that company may have 4 product categories I'd be looking into. Well, for something like that, I mean, that's pretty standard, I would say. And I was using, things like ARIMA. And at the time, I think some better algorithms were coming out. So I was using linear regressions and some more high performance algorithms than that, like a GLM. But it certainly wasn't, what is being asked of today, which is, thousands and thousands of time series. So if I fast forward from 5 years ago to now what I'm seeing is it's a lot more daily time series because we have data at a much more granular level. Think about it like Google Analytics. Every company has a website. They have data sometimes at the second or hourly level. You have product data from when purchases are being made on your website, or when people are making purchases. So this is a lot of hourly or primarily daily frequencies that we're wanting to identify information at, because you can really start to see some of the big spikes in demand. You can start to really be able to predict and align events that are happening on your website with surges in demand that are happening in your products database. And you're able to do this for everything. So it's not just, aggregating to, say, like 4 different main product categories or 4 different sales regions, like north, south, east, and west. Now it's every product in that sales region, every product in that other sales region. That is a time series group. And that's why the scale becomes super important. You need to be able to handle that. So we also are seeing that ARIMA isn't really being used as much for that. Because we're now in the daily frequencies and we're needing to adopt some new technologies and some new tools. I'll talk more about those here in a few minutes. So what I want to talk about is what every company now wants is a high performance forecasting system. And there's 3 properties. So the first property is that company wants you obviously to improve results. So just for example, when I was working at my last company, improvement of say 10% or so would save that company millions and millions of dollars just because of the scale that they were operating at. So this is why it's super important to get these forecasts as accurate as possible, because all of these decisions run from these forecasts. So the company takes that forecast, they then schedule out all of their personnel that they're going to need, they then schedule out all of the materials that they're going to have to purchase. They schedule everything from the forecast. And this is why that company is investing in some smart data scientists to hopefully get their forecasting under control and much more accurate than before, because it'll pay them dividends if they are able to accomplish this. So that's property number one. You want to be able to deliver the best possible results given your resource constraints. Property number two of a high performance forecasting system. Your organization needs to know if there's an issue going on with your forecast. So if your forecast is not forecasting as well, that needs to be alerted. People need to know about that. You need to be alerted from that. So you want to understand, which forecasts out of the 10,000 are doing the best, which are doing the worst, and be able to have some sort of way to measure that accuracy. That's really important for the organization. Otherwise, if you're giving them bad forecasts, then they're making bad decisions, and that's costing that company money. So you need to understand which time series models are working well, which aren't, and which and have a way to have some sort of feedback if your forecasts are going haywire. And then the third property of a high performance forecasting system is that it's scalable from one to many time series. So your organization has lots of data, and what you can see here in the background are a bunch of different groups. This is website data, and these are all sorts of different pages on that website. And you can see we're having to make forecasts for each one of these web pages to understand the web visits. You can do the same thing for all the different products and all the SKUs, SKUs that are in your company. And that's what the company wants, is at that most granular level. They want to understand how that what the demand is going to be for those products, and what they need to prepare for in terms of having the right people, the right number of staff, and so on. So that's what the company wants. Those three properties, and those are the three properties. So it's first, improving results, high accuracy. Second, that needs to report the accuracy if something's going wrong. And then third is scalability. So you want those three things. So that's what I was seeing about a year ago, is that the businesses have been shifting from kind of what I was doing back, in 2015 to now wanting a more scalable and automated system. So I started researching high performance forecasting systems about a year ago. And this is just at a high level what I found out. And this is kind of shocking to me, because you're talking about somebody who was primarily using ARIMA and doing monthly forecasting, and seeing what the business needs are now. It's completely different, and it's requiring a new set of skills. So what I started doing was I actually focused on competitions, because this is where I saw on Kaggle and on some of these other competition websites that there's all these different forecasting competitions going on, and it actually mimics quite well what I was seeing in terms of the what companies are asking for. So it turns out that competitions have the exact same properties that we're looking for business high performance forecasting systems. So one is scalability. These forecasting competitions have a lot of time series groups, and you have to scale your analysis up from one time series to many. And that requires some level of automation. Number two, they're really focused on maximizing results. So improving that forecast accuracy, trying to make it as accurate as possible. And then also, this is something too, is that most of the competitions, there's some sort of benchmark out there. So they're reporting accuracy. They aren't necessarily doing it on a per SKU or per part number or per product level, but there's an accuracy reporting involved. So what we can do, or at least what I thought we could do when I was starting out my research, was to try and learn from these competitions, because what they're competing on are very similar to the projects that I was seeing in businesses. So I focused on 4 different competitions. The first one was in 2014. It's the Walmart recruiting and store sales forecasting. The second one was in 2018. There was an M4 competition where they analyzed 100,000 univariate time series, and they were at different periodicities. So some were hourly, some were daily, some were weekly, monthly, quarterly, and annually. The third one is the Wikipedia website traffic forecast competition, and that was held in 2018. And then the last one is the most recent, which was just held this year, is the M5 competition. And that was, again, done using data from Walmart, but at a very, very granular level. So I'm just going to go through some of the results that I found interesting in my time series course. I do a 30-minute presentation on this, talking about all of the insights that I found. But we'll, in the interest of time, we'll just stick to some of the key ones that I wanted to present today. So the first one, this comes from the Walmart Sales Challenge in 2014, and this is the second place solution that I found interesting. And this was because it really focuses the power of using a bunch of different kind of techniques to be able to then combine them all into one machine learning ensemble. So what this gentleman did, his name's Srihari Jagannathan, and what he did was he predicted the second place solution, and the technique he used was he used ARIMA, random forest, KNN, and 3 more machine learning models. So what he was able to do, though, was take advantage of this technique called ensembling, and he says in here in his write-up that he combined 6 models, 6 bad models, to make one good one. And that's the case. That's the power of combining some of these newer technologies, which was machine learning at the time in 2014. It was pretty cutting edge. And then also the idea of averaging, model averaging. So that's one of the key insights that I found, was that, we're seeing newer techniques being blended with some of these other techniques, some more classical time series analysis here with ARIMA, and then machine learning for this particular challenge. So that was the first one. The next key insight that I saw was we're seeing the emergence of deep learning. And this is the winning solution to the 2018 website traffic forecasting competition. And this gentleman, Arthur Solon, he used an LSTM. And this is the first time, I think, in competition that I saw an LSTM being used. I also noted that the M4 competition, the winner of that competition, used a recurrent neural network. So what he says here is that the recurrent neural network is kind of like an extension of an ARIMA model, but much more flexible and expressive. And the idea here was that using this LSTM, he was just able to run it for longer and longer, and it ended up getting pretty accurate solutions. He also used some feature engineering as well, but the main strategy that really won him this competition was using deep learning and using something that other people at the time weren't using. The next one, this is the M4 competition. So this was also in 2018. And this was the 100,000 univariate time series. Some of them were, hourly, daily, weekly, monthly. The key here is that no one had any idea. There was no external regressors or anything. I don't even think they had timestamps for this. It was just univariate time series, and they were told whether or not it was an hourly series, daily, weekly, or what. And the key to this competition was, again, the emergence of deep learning for this univariate type of analysis. This Uber Technologies ended up getting a much better score than the closest competitors. The SMAPE, I believe, is what it was judged by. Ended up getting a 9.4 versus a 6.6. And then the next closest was 5.7. So this one was clearly doing something totally different that was helping them get so much better results. Then the most recent one, and this is this kind of takes me back to what I used to try and do when I was forecasting, which was really take advantage of feature engineering. So this is the M5 competition, and this is the first place submission. So what this person did, and unfortunately I don't have his name up here, but what he really focused on was feature engineering, creating features from the different variables. So like calendar features, lag features, and then rolling features, and then utilizing primarily the light GBM, which is kind of like XGBoost for machine learning, and then making several models and then stacking those together. So this is, again, ensembling. But what we're really seeing is the value of feature engineering for this type of data that was used in that particular competition. And this competition, in my opinion, most represents what's being requested for in the industry right now, which is to be able to analyze one product over time, and actually lots of products over time, like, you know, tens of thousands or hundreds of thousands of products, and be able to provide forecasts for each one of those products. So that's what this competition was all about. And the key to the win was feature engineering combined with machine learning, combined with ensembling. So the takeaways that I'm seeing out there as I'm going through and doing this research is that the first one, feature engineering, was really important. So I saw this in the first place and third place of the 2020 M5 Walmart Challenge, using calendar features, lags, rolling features, and those sorts of things. So feature engineering was super critical, especially when machine learning is involved. The next one, experimentation and ensembling. So they're not just going with one algorithm. They're going with 10 or 15 or 20 different algorithms, and then or creating, maybe it's just one algorithm, but they're making 15 different models from, and then combining those models. So we saw this, that's one of the keys to the win for the first place 2020 M5 competition. And also the second place in the 2014 Walmart Challenge. And it actually, that person almost won the competition. They lost it in the last couple of weeks because the other submission, and that leads me into number 3 here, is knowledge of key events. The other person that person was competing against recognized that there was a holiday sales surge at the end of December, or I should say end of November. So they were able to improve their accuracy by shifting around some of the sales by knowledge of these key events. So that's the winner of the 24 Walmart Challenge, ended up getting first place in the last 3 weeks of that competition. Otherwise, this person that did the ensembling approach, they would have won it. The fourth key takeaway is machine learning. And we're seeing this, especially as we get into the daily time series, anything with seasonal patterns, anything with events, anything with calendar features that have some sort of seasonality and trend associated with them. We saw machine learning claim the first place in the 2020 M5 competition, second place in the 2014 challenge. And then the final takeaway is deep learning. So we can't just focus on the machine learning side of it, because deep learning is also becoming very useful. Recurrent neural networks won the 2018 M4 competition, and that was with website data. And then it also performed very well in the 2020 M5 competition. I think the second or third place had some sort of deep learning component to it. So those are the key takeaways and some of the technologies that I'm seeing that we need to start reviewing and becoming better at and learning if we want to really make this transformation into the high performance forecasting system that businesses want. So what I then did, so now that I was armed with this information, I saw, what the competitors were using in these Kaggle competitions. I felt pretty good about, what organizations want. And I now have kind of, a strategy. I'll just kind of maybe try and use some of the same types of techniques that these competitors are using, and then build a training out of it. And the idea was to build a course out of it. Well, that sounds all well and good until I actually tried to build the course. Because it was, I think I did several iterations and I almost gave up probably half a dozen times. But when I researched the actual software that's out there for time series machine learning in Python and R, it wasn't pretty. So I researched, kind of in machine learning, what these guys were using, and then some of the newer packages out there. And what I found is that I was typing about 2,000 lines of code just to make a multi-model forecast with like k-nearest neighbors and, some of the other forecasting, random forest XGBoost. So trying to replicate, what even the 2014 solution was not easy, because I was writing so much code. So I felt like this. And I kind of went back to the basics and I said, hey, what if, there's a better way? Because I saw the emergence of the tidy models framework in R, and I had been using it. I taught it in the 101 course, and I really loved the idea of how easy it is to make machine learning models. And but it just wasn't set up for a forecasting framework. So what I did was I stopped the coursework, took a pause for a couple of months, and I really focused on building out a full-fledged forecasting software that integrated some of these machine learning techniques into it from the Tidy Models ecosystem. And I called that Modeltime. So, and I'll say what it claims. So if you go to the website for Modeltime, you'll see, what it claims. It integrates classical models like ARIMA, exponential smoothing. It also integrates machine learning from the Tidy Models ecosystem. And then I also integrate Profit, which is one of the better algorithms out there for forecasting a lot of this daily data. But to me, what it really does, and why I love Modeltime, and really what I wanted to achieve out of putting it together, was increasing my productivity, decreasing the amount of code, and improving the speed of experimentation. So when I'm having to build, or when I want to build, many, many models, I want to be able to come through that process very quickly. And that's what this now allows me to do. So I want you to be able to use it. I open sourced it. One of the keys to it is the streamlined workflow. And it's very simple to use. It's mainly 3 functions and then a couple of different helper functions. So you put things into a Modeltime table, you then calibrate it against some sort of testing data, and then you refit that once you've gotten your accuracy and once you've seen the forecast and you're happy with the models, then you refit it to some new data or the full data set, and you can make the future forecast. So it's very simple and straightforward. It's easy to get up and running with it. And what it really helps me to be able to do is to be able to experiment with a lot of different modeling techniques. And we saw this in the 2014 Walmart challenge, where they combined a bunch of different ensembles. This is what, in my mind, we need to be very comfortable with doing, is being able to build lots of different models, test them out, compare them, see which ones are working, and then eventually be able to ensemble them as well. So this is the output of one of the, I think it's module 12 in the course, or might be module 11 in the course, where we do machine learning models. You make 28 different machine learning models, and we sort them by RMSE, and we see which one's the best, and we compare and contrast. So it's pretty cool. And what's really nice is Modeltime integrates with the Tidy Models ecosystem, which has the ability to hyperparameter tune, do cross-validation, and do model stabilization. So I've been also adding in a lot of time series feature engineering as well, and time series sampling. So we're now able to not only just build the models, but we're also able to tune the models. And this is really important because if you want to have a stable model like the 2015 M5 competition, the light GBM model is, if you don't tune that model, it's just like XGBoost. It's going to way overfit your data, and it's not going to generalize very well. It's not going to be stable. So you want to stabilize it by tuning, and you can do that now with the Modeltime framework. That's something that you can't do with any other framework that I saw out there as I was doing the research in the software. Okay, so the end goal was to really expedite my forecasting efforts, and this is how I felt once I had put the Modeltime package together, and I saw how few lines of code. So I started with like 2,000 and I ended with like 300 after implementing Modeltime. So I was pretty psyched about that. And then, so what about feature engineering? We spent a lot of time here talking about Modeltime and machine learning, but that's actually only one small part of what you need to do in order to be able to do these high performance time series forecasting systems. So what about feature engineering? That's the other biggest, one of the biggest pieces. Well, we saw here in the M5 competition how important feature engineering was, right? So we've got price features, we've got calendar, lag features, rolling features, and we want to be able to build different models from these features. And we want to be able to basically create these pre-processing recipes very easily, but also be able to explore and see why things are happening. You know, why is this feature really important to that model or not? So this is where it gets really interesting because, in my opinion, the feature engineering, which comes after you've visualized, which comes after you've simplified, which comes after you've transformed, and this actually requires quite a bit of iteration as well to be able to figure out, you know, which features are going to be are important. So before, again, just trying to recreate, you know, some of these different approaches to the winning submissions, I found myself writing like 4,000 lines of code, and I'm not even done with the analysis. I'm not even to machine learning yet, but I'm just trying to, like, you know, recreate and understand, you know, what they're doing. So, you know, I kind of felt like this again, and that was like the second point where I'm like, all right, I'm done with this. I'm giving up. Don't worry, guys. I didn't give up. So I made Timetk, and actually Timetk, I didn't make it. Timetk was already a package, but it was a much smaller version of what it is today. So if you go to the website for Timetk, what it claims is it does feature engineering, it does data wrangling, it does visualization, and it does pre-processing. But what it really does is it increases productivity, it decreases your code, and it improves the speed of feature exploration, which is super critical when you're coming through these massive time series problems. So it's a massive time booster, and and I heard from one of my students, it's like cheating. He saw the pad by time function, and he said, you know, hey, this is like cheating, how easy this is. And that's, to me, that's a compliment, because that's something that used to require, you know, many, just one simple operation, which is filling in missing values in a time series, used to require a lot of code. And now that student is able to do it in like one line of code. So that's what Timetk allows us to do now. So the feature engineering component of it is now simplified as well. So we're able to make all of these different features, and we're not only just making the features, but we're exploring what the effect of these features have on the model using functions like plot time series regression, which uses a linear regression, and it shows if you change different, you know, values that you add to that regression model, what happens to your fitted values, and then how it changes the some of the parameters and some of the metrics on that model. So it makes things super simple. Okay, so now we got feature engineering done. We got that squared away with Timetk. I've got Modeltime now for machine learning, making lots of different models and doing experimentation. But what about deep learning? Well, it turns out, so we know deep learning is important. It's got the first place solution in the web traffic forecasting. It also got the first place solution in the M4 competition. So what are we going to do, though, to be able to kind of increase our productivity to build these? And it turns out that another company has already tackled this problem, and that is Amazon. So you may be familiar with AWS, or you may be familiar with the company Amazon, but what they also did was they open sourced this product, this software package called GluonTS. And what it does is it provides a convenient wrapper to building LSTMs, to building, and you can, don't get me wrong, just like TensorFlow, you can build, these complex neural networks from scratch if you want to do that. But what it does is it wraps up these really basically deep learning models that have shown to get results and have papers on them, like NBeats, like Deep AR. And you can see this is the NBeats one that I have, and it's got a little link to the paper on them. But they've actually implemented this in a consistent framework that is high performance, and it's all based on their MXNet deep learning framework. So it turns out that we have a package already. Now, it is written in Python, so it's something that if we're in R, we have to use a reticulate in order to be able to utilize it. But it's something that basically checks that last piece off the box. So we don't have to write thousands and thousands of lines of code. We can do our data wrangling with Timetk. And if we want to do deep learning, we can use reticulate and pull in GluonTS just right into our R session and be able to run it. So that's what I saw. And I was really happy when I saw that, because I did not want to have to build a deep learning framework. So then the last piece, what about scalability? So we've been talking a lot about machine learning now, about feature engineering, about now deep learning, but that's just, one time series. How do we scale it up? So it turns out there's another package that has solved this problem as well. And there's many parallel processing frameworks, but there's this one called Future in R. And what this does is allows us to do asynchronous programming, and it's being adopted very heavily within the various R ecosystems. For example, in the Tidy Models ecosystem, there is a experimental backend right now that is getting ready to be released inside of Tune for hyperparameter tuning to be able to do that in parallel. And this is, I've actually already integrated that into my course, but it's pretty sweet. You're able to get a 3 to 5x speed boost because hyperparameter tuning is very expensive. It takes a while to do it. So you're able to run everything asynchronously in parallel. That not only affects and helps us on the hypertuning side of things, but it also helps us with time series groups. So when you have 10,000 time series and you have to run that on a server, you need to be able to do that in parallel. And servers have lots and lots of cores that you can spread out those computations to. So being able to be comfortable with using the feature package can take that 10,000 time series and compress that down into, say, 3 or 4 hours. So it makes things a lot easier. Okay, so we've talked about some newer technology out there, and hopefully you understand that there's definitely some new challenges out there with what businesses want, and that's the concept of the high performance forecasting system. But there's some new technology that we have available to us. So we just need to learn how to utilize it in a consistent framework. And then that's going to be your key to unlocking what that company needs. So this is the bonus that I'm going to be giving everybody today. This is the forecasting cheat sheet. And what it does is it provides a repeatable framework for being able to produce high performance forecasts. Now, it's high level. But what I do in my course is I walk you through every step of the way exactly how to utilize this. So this is the key to unlocking everything. It's super valuable. I can't tell you how valuable this is. And this is what the forecasting cheat sheet looks like. It's 3 pages. So I'll zoom in on it for everybody. The first page covers forecasting with external regressors. It starts with the data import process. In the course, I show you how to simplify the data, how to clean the data, how to pad it, how to do everything you need to do. And then you have to extend it through your forecast horizon. And then you can expand it by adding lags, events, and X-regs. And then what we do is we split that, and we have now a future data set and a data prepared. This future data set is eventually what we forecast on, and this data prepared is what we do our model training on. We split that up into training and test sets, or cross-validation sets and test sets. And then we figure out what model parameters we want to use. We get residuals, we get confidence, and then we can refit everything on the full data set, the data prepared. So now that we have our information, we can now make our best forecast, and that's what the workflow looks like. I just did it in about 10 seconds or 30 seconds of talking through it, but this is the value of the high performance forecasting course, is you go through every step of the way, and you're given real data, real daily data with events in it, with external regressors that you have to go through and do this process with. The next page is the model time workflow. So this piece here where we're modeling and we're doing training and refitting, that's all covered by the model time workflow. So it shows you which functions you need to use, and you can always refer back to this, and it shows you what each one does and gives you kind of the step-by-step process. Now, this doesn't cover the hyperparameter tuning, so that's what the third page is for. Hyperparameter tuning is basically this step here. So if you go back to this first page, it's where you see cross-validation. That's what this piece is. And this cross-validation is basically being expanded on the third page, and you start your cross-validation. You first come up with a cross-validation plan. You either have a sequential model, which might be like a REMA boost, or you have a non-sequential model, which might be like profit boost. And I explain what those are in the course. And then you move on to hyperparameter tuning. So you have to create a model spec that identifies tuning parameters. You then create a grid for your parameters using this grid Latin hypercube function. Then you move down into tuning. So you have the actual hyperparameter tune, and this is where you want to set up your parallel processing to speed things up, because it is a very expensive operation. And then what most people do is they just stop here, but you actually want to review your parameters, and you can sometimes take it back here to the first part and be able to run it through again by fine tuning and honing in on some of your parameters, reducing the ranges of those parameters, and you can get better results. And I think I did a 3-step in the course. I do a 3-step, so 3 rounds of hyperparameter tuning, and I was able to go from I was able to increase the accuracy 5% by doing just those 3 rounds of hyperparameter. So if I would have stopped at just one, it certainly wasn't the optimal model, certainly not the most stable model. And then once you come out of that, you've got your model parameters and your residuals, and you're ready to just kind of continue on the workflow. So sounds kind of complicated, but if you learn that workflow, you're able then to repeat that for almost any time series problem. So that's the main benefit of this cheat sheet. Again, super valuable. Once you learn it, this unlocks everything. So what's the plan to learn the cheat sheet? And that's where I want to talk to you today about my new course. It's called High Performance Forecasting. So basically you want to be able to give businesses what they need, right? So we're in 2020 now. Companies want forecasting at scale. They want automated systems. They want all the bells and whistles. And this is what you can now give them after you take this course. So you'll be able to produce time series forecasts at scale. So it's a lot to learn. And if you think about it, we talked about several different pieces to a high performance forecasting system. You've got feature engineering over here, where you're having to create features, having to make lagged features, have to test out rolling features, and so on. Then you have to learn how to build many different models and experiment with those. So you have to build lots of models and compare them. And then you move on to tuning and cross-validation. So you take your best models and then move them on to the next stage, which is the more expensive hyperparameter tuning. And then what you do is then you have to figure out how to scale that up to thousands and thousands of time series. So that's what the course teaches you. It walks you through step by step. So you have a consistent framework now that you're able to actually come through this. And I break it down very detailed so you can repeat it. And that's the idea. And then also so you learn something in the process. So let's talk about this course now. I really created this course because I wanted to compress my 10 years of experience forecasting, my year of research. I want to bottle it up and package it up so it's as simple as possible, so you can learn what took me years and years and years to learn in like 3 months or like 12 weeks, 8 weeks, whatever it takes you to get through the course. One guy's, he's almost through it already. Basically, I want to be able to help you so you can accelerate your career, right? Because imagine you getting the skill now that no one else in your organization has, which is to be able to build these high performance forecasting systems, how valuable you're going to be to that company. So that's what I designed this course for. I want you to become super valuable to your company. I want you to realize that this is something that companies genuinely need, number one, because I'm seeing requests for it from my students. They're reaching out to me saying, hey, we don't know how to do many time series. Hey, we need to learn how to increase accuracy. Hey, I saw this technique, deep learning, being used. What's that all about? So this is the course that will take you through in a step-by-step fashion. Everything is broken down for you so you understand all of the different pieces, and it's applied and it's project-based. So you walk through with you have a specific goal with projects. I think it's the email subscribers. I give you real email data that's messy, that has events in it, that has spikes, that has anomalies that you got to clean. And I show you how to do all of that stuff. And I walk you through the process every step of the way. So, and then at the end of the day, we teach you not only how to do it, the bulk of the course is figuring out how to do it for one time series, because if, there's no good in scaling something up if you can't do it just for one time series. And then eventually what you do is you get to, once you learn the process for one time series, you can then scale it to thousands, and you can make it very, very accurate for all 1,000. And that's what these Kaggle competitors are doing. So that's the course in a nutshell. This is the curriculum. So if you want to understand specifically, if you're interested in the course, if you want to understand specifically what's inside it, the feature engineering, there's about 9 hours of video material. It will take you probably several weeks to complete this, but there's 1.5 hours of video just on visualization, 1.5 hours on data wrangling, 1.5 hours on transformations. There's the first challenge, which will take you about 30 minutes to go through the video, just the solution on. And then there's 3 hours of feature engineering. There's an introduction to feature engineering, and then there's an actual applied advanced feature engineering where you have to create like rolling lagged features, which was one of the key features in the M5 competition. And then there's a second challenge where you actually have to apply it, all the same techniques that you just did. You have to apply it to weekly data. That's revenue for the company. So it's a completely different data set, no longer emails, but the same techniques and strategies that we're using work on the new data. And that's how it goes. Once you learn these techniques, you can apply it to almost any data set. The next piece of the curriculum is part 2 of the course. And right now there's about 15 hours. I'm still adding the ensembling and the scalability with time series groups. Those will be released in the next coming weeks. But right now there's 1.5 hours on ARIMA, an hour on profit, an hour and a half on exponential smoothing and TBATs. Then you have your first challenge, it's challenge number 3, but it's the first one in the machine learning. Then there's the machine learning algorithms. You have 4 hours on that. So that's a big one. Then there's boosted algorithms, were something that I've developed specifically in my model time package. And that's one of the innovations in model time. Then there's hyperparameter tuning, which I show you how to tune the boosted algorithms. Profit Boost ends up winning that one. And we show you how to stabilize that algorithm because it certainly overfits right out of the gate. And then there's ensembling, which I'm working on right now, and scalability with time series groups, which I'm also working on. And then part 3 of the course is deep learning. So you'll be learning how to use Reticulate to combine both R and Python. And then you'll be learning how to specifically utilize the GluonTS package, the suite of functions that comes with. So NBeats, Deep AR, Deep VAR, all of these functions that are capable of beating the M4 competition winner, his results, beating the web traffic forecasting's results, because these are the top of the line algorithms that are integrated in GluonTS. So that's the course in a nutshell. It's my biggest project yet. It's been my most difficult project yet. I almost gave up several times, but I'm glad I didn't. It's really powerful. So if you want to learn how to build a high performance time series system, here's what some of the people were saying about it. So this is my buddy, Jonathan Regenstein. He is the author of Reproducible Finance with R. He's also the head of quantimental research at Truist Securities. And one of the things that was cool is he put this up last week on LinkedIn, where he's talking about pad by time, and how he says here he's already picked up a couple super useful new moves like pad by time. And then I think one of the comments, that's where one of the students in the course said, yeah, he felt like when he learned this one, he felt like it was cheating. So it's definitely, you're going to learn a lot of super useful new moves. It may end up feeling like cheating sometimes, but you know what? It's cutting down the amount of code you have to type, and it's making you more productive. This is my other friend, Raphael Nicholas Fermancota, Nico for short. He is the co-founder and CEO of 162 Group. He's also a faculty member at the University of Singapore, which is like the MIT of Singapore. What he loves about the course is that it's project-based, and he's finding it interesting utilizing the machine learning technologies, and he's also excited for GluonTS, which is coming in the course. So if you're interested in taking this course, I actually have a full system developed. It's in Business Science University. And the key here is no matter where you are at right now, it will take you to the expert level in about 6 to 9 months. So you're going to go through that transformation. There's now 5 courses in the system. So we now have the new time series course that we've just added to the curriculum. And basically, so if you're a beginner, and if you're on this call right now, and if you're listening in and you want to take advantage of time series, you're not going to want to jump right into it. What you're going to want to do is take 8 weeks, set that aside, and get your foundations set with this first course, which is R for Business, and it teaches you the tidyverse. It teaches you all of the foundations of machine learning, like what algorithms exist out there, like what XGBoost is, what are the key parameters, those sorts of things. Because if you jump right into the time series course, probably the first part of it will be okay, but once you get into the second part, you're going to be you're going to feel like a fish out of water, and I don't want to see that happen. But if that happens, there is a solution. You can always go backwards to the 101 course. Then there's the 2 pieces, which are in the advanced curriculum, which is your advanced machine learning and business consulting, and the time series component, which I've just added. So the business consulting, this is the 201 course, and you learned automated machine learning, you learn business consulting, you learn explainable machine learning, all of the things that you need to be able to do to tackle a large scale data science project for your business. Then we have the new time series course, and this will take probably about 12 weeks to complete. And this is where you learn the model time package, Timetk, GluonTS, and it's really focused on high performance time series systems. Then what you need to do is you need to continue on, because now you have all this data science, but you need to be able to distribute it in your organization. And you can't do that unless you build dashboards or web applications. So that's what the last two courses do. There's the first course, which is the 102, which teaches you how to build web apps and dashboards. It teaches you HTML, CSS, and this tool called Shiny, and you build your forecasting dashboards. Then what you do is you move on to the full stack, because this is what allows you to leverage AWS and really develop a full stack web app that links a database, that has users, that has security layers. You have to use Docker and some software engineering technology like Git and Docker, and that's what helps you be able to distribute your awesome forecasts to the rest of the world. So you want to be able to learn the full system, and everything is integrated and it all fits in. So each course you're learning different techniques, but you blend it together and you become really well-rounded. You can do not only have your foundations, but you can do automated machine learning, you can do time series, and you can build web applications. I do have a special perk for everyone on here today. It's a 20% off promotional code. And David has generously put that in the chat over there. I see that. And what this will do is it'll save you about $695 versus buying these courses individually. It's a 20% off coupon code. And the nice thing is that if you enroll in the full package, you get an additional $50 off per course. So that's the advantage of doing the R-Track bundle. Otherwise, you can also buy these courses individually and just use this coupon code Time Series Launch. It will expire September 21st, which is Monday, because that's when our course launch event ends. So you won't be able to take advantage of the 20% off after that. So definitely jump on it if you're interested in any of these courses or the full R-Track bundle. Check it out. It will change your life. It will accelerate your career. I guarantee it. And you'll have a lot of fun doing it. And you'll have access to 1,000 other students that are also taking the course. Oh, and by the way, we have almost 200 students. We just launched last week. We have almost 200 students in the 203 course already, the new time series course. So it's people are loving it. We have some time here now at the end. I'd love to handle any questions, David. I don't know if anyone's been asking in the chat.
Oh, sure. Yeah, we got a lot of questions. I'm going to also put a link in the chat. There's been some questions about the pricing, and I wanted to mention that if you work at an organization that has a reimbursement plan, you can look into seeing if your company can pay for the courses as part of an education. And Matt has a nice article about how to pitch this to your manager. Yes. I'm going to put it in here now.
Okay, you got it for him. Good.
Yeah. So take a look at that, and that'll help offset some of the price for you.
Yeah, about a third of our students are getting the courses paid for by their companies, and their companies are benefiting big time. So they're happy to pay for it. Yeah. I would definitely look into that. It's usually an underutilized thing in your organization, but you may have a reimbursement policy.
Yeah, and you all may not realize it, but a lot of companies, they have this money set aside, and unfortunately, it's not all used up by the end of the year. So it's there to be used. So definitely look into it.
Yeah, your companies are pulling for you to learn this information. They want you to be able to know how to do this stuff because, like I said, a 5 to 10% reduction in your forecast error, that's going to save your company millions of dollars. So they're happy to spend a few $100 on a course if that's the potential payoff. I mean, it's an instantaneous ROI. So definitely look into it.
Definitely. Okay, so we got a lot of questions. We're going to try to cover a few of them in maybe like a quick fire succession, just to see how many we can get through.
Sure.
So Rishi asks, as a newbie, where to start in time series forecasting?
Oh, that's a great question. So, hey, Rishi, thanks for asking that. So the idea here is that time series is really challenging to learn. In fact, I know people who have studied it for years and years, and they still feel like they're spinning their wheels sometimes. And honestly, probably the first couple of years as a data scientist or as a business analyst, I myself felt that way. So the best way, in my opinion, to start the 101 course is a no-brainer, because in 8 weeks, you're going to learn, it's going to cut probably a year off of your training time. So that's this course right here. It's the business analysis with R. It's going to teach you all the foundations. Now, it doesn't go into all the detail on time series. So once you take this course, you're then able to level up with the high performance time series course, which gives you all of the time series information. So again, this is information that has taken me a full year to research, a full year to build the software, plus it's taken me 10 years of practice in order to feel like I know what I'm doing. You know, you can do it a lot faster now. This will take you 12 weeks. So that's the way to go.
Great. A few people are asking, can they get a link to the cheat sheet?
Okay, so what I'm going to do is tomorrow morning, I'm going to send out the video. I'm going to put it on YouTube. I'm going to send out the video, and anybody who is in attendance today is going to also get a link to the cheat sheet.
Okay.
So you guys are going to be able to download it. Unfortunately, I can't give you a link because I don't have it on the internet yet. I've kept it private, but I will be giving it out to everyone who is in attendance today.
Okay, great. Sounds good. Patrick asks, does Modeltime currently have as many models as the forecast package in R?
It has all of the forecast package models, plus it has profit, plus it gives you access to every model in Parsnip, which means you have access to way more of an ecosystem than the forecast package.
Okay.
And it actually uses forecast under the hood. So
yeah, that's true. Okay. This was from an anonymous attendee who was wondering the cost of the course, which we've covered that. Also the duration. I think maybe you can say how, I know you covered this, Matt, but if you could say how long is a time series course, and then maybe give an overview of how long the other courses are as well.
Sure. So each course in the system, the best way to kind of visualize this, let me go back here, is with the R-Track plan. So it's going to take time to, any time that you want to level up to the extent that you're going to level up. But I can guarantee you there is no faster way than taking this program. If I was in your shoes right now and I was starting fresh, hands down, this would be the way I go. There is no questions asked. It'll take probably about 8 weeks or so to get the first course under your belt. That's with about 5 to 10 hours. So it's designed for a working professional, and it'll take you about 5 to 10 weeks if you're doing a little bit each day or a couple hours each week, like 5 hours each week. It'll take you probably eight weeks, maybe a little longer if you're only doing 5. These two courses here combined will take you about 20 weeks. They're extensive, but that's I go into a lot of detail on the most important aspects of time series. I go into a lot of detail on the most important aspects of automated machine learning and business consulting, and how to integrate data science with the business. So it just takes a little bit of time, but you're going to love it. I mean, it's exciting. It's fun. And then the web apps too. I mean, there's nothing cooler than actually building a product, an actual, application. So that'll take about 12 weeks. Those courses are a little bit faster. They tend to be a little faster to complete, just because you're more focused on building an app and less focused on, having to learn what an algorithm does under the hood, which just takes time.
Yeah, definitely. Okay, Yash asks, do you cover the question on when to use machine learning versus deep learning versus time series versus ensemble? I guess when to use what?
Yeah. And my answer to that is experiment with all of them.
Yeah.
So that's the idea here, is that's why I built Modeltime, is you don't know going into something what's going to work. You may have some, experience that kind of says, hey, probably ARIMA is going to work better here. But you know what? You may be surprised. And it all depends on, you go off of results. So in the course, I go through the process of actually how, like you build, I think 30 plus models just in the machine learning part of it. You build a lag model and a recipe model and a spline model that has a bunch of calendar features in it, has a bunch of some rolling features in it. And so for every model type, you're building 2 models. So if we go through 15 model types, there's 30 models right there. And then in addition to that, you have ARIMA, you've got ETS, exponential smoothing, TBATs, and so on. So you're building 35 plus models, and you don't know what's going to work. So what you end up doing is you put it into a table and you compare them. And this is before you do your hyperparameter tuning and everything. And it looks something like this, where you've got literally 30 plus models here. And you can sort it by RMSE and you keep track of all of that. So that is what Modeltime helps you do. And then you take your top models, which might be like these top 5 or so. And then that's when those are your candidates to move forward with hyperparameter tuning, because hyperparameter tuning will take you maybe a couple hours, maybe an hour to do all the hyperparameter tuning for a few different models. And if you're talking about doing it for 10,000 time series, that's expensive. So you need to be very selective in what you're doing, and you have to understand your resources. So I walk through all that process.
Mm-hmm. Definitely. Okay, there's a question on, do we get support from you if we buy the course? What's the course structure methodology like?
Yeah, so I'm on my Windows machine right now. I can pull open the Slack channel. So support-wise, the easiest way is, I think this is the right one. Yeah, this is my data science for business track. Basically, this is how you'll reach out to me. There's a Slack channel that allows you to post questions by each one of the courses. So the 203's in here, and you have your 3 different parts, and you can see people are posting questions in here already. That's how you'll get help for the course. You can ask anything in here. I'll do my best to help you. If it's outside the scope of the courses, I'll have to kind of feel it out, but in general, I am trying to help. You can also ask the community if you have just general questions as well, and you'll get people responding to you. So it's a pretty good system. It's a private Slack channel that we have, I don't know, I think we have around, this channel here has 982 members. So there's quite a few people. If you have questions, they'll definitely get answered.
Yeah.
And you have access to me in there as well.
There's a variety of questions around different algorithms and books and just different sort of, how do you approach this? Will I be taught this?
This is brand new. Yeah, everything is brand new here. Like, you got to understand, you got to not throw the books out, but you have to set them aside for a second and say, hey, because everything is written around the 2015 Matt, who was sitting at his cubicle trying to do an ARIMA on on some revenue data. Fast forward to now, we're in a completely different situation where the rules don't necessarily, we're now dealing with daily data. We're now dealing with time series at scale, and the challenges are much, much different, and we have to learn from what we're seeing get results. And this is the best thing that I can tell you, is do the research yourself. I've already done it for you, but if you want to really dive into it, do the research yourself. Check out these competitions, check out the winners, check out what they are doing. It's not what you think and what we've been taught in school, which is, just econometrics, normal stuff like a linear regression. They're not using linear regression. They're not using, for the most part, they're not even using ARIMA. They're using machine learning, deep learning, and a lot of these different tools and techniques that are brand new.
I think that also is a good setup for maybe if you could quickly explain your approach to using data science for business, sort of your 80-20 rule and getting results, and
Yes.
why you focus on what you focus on?
So when I do teaching, and when I try to develop a course, and when what I specifically focus on is the most important aspects, and I call it the 80-20. And I mean, this is not a new term, but it's the 20% of the content that's going to get you 80% of the results. So for the time series course, if we go to the curriculum, the curriculum is focused on the key aspects of time series that I found super important when I was going through. So that's feature engineering, that's modeling and experimentation, that's tuning and cross-validation, and that's scalability, and that's using some of these different techniques like machine learning and deep learning. So if you go to the curriculum, you can see it's designed around that. You'll also notice that certain things aren't talked about. Like I got a question the other day about Garch. It didn't make the cut, because that's going to take another two to 3 hours to explain the concepts and to show you how to implement it. And it's not going to give you the benefit that I'm seeing from the competitions and some of this other stuff. So I definitely plan on still handling that. I'll probably teach, because I'm going to, in Modeltime, integrate Garch. I'm going to integrate several other modeling packages that are out there for time series that I know people want, like Bayesian time series. But it's just, I have to make cuts, and I have to be able to focus in on what's the most important. And if it doesn't get results, the 20% that covers the 80%, then I can't afford to spend time on that. I need to focus on what's most important. And that's what accelerates you. That's why you're able to learn so fast. You're able to get up and running the first day. You're able to, by the first week, have a serious set of tools that you're able to apply to your current projects at work. So, and then by the end of the course, you're a machine. You're unstoppable. So that's the end game.
Yeah, I'm glad you mentioned that, because there's always questions about maybe something that you don't have listed here.
Mm-hmm.
But the point is that you've gone through all the heavy lifting to figure out what works, what do businesses need, and then focusing on those concepts to get you the maximum result.
Yeah, and I have a running list of things that I'm going to end up needing to include in learning labs, just because they are important topics.
Sure.
But it's just like I get a question now. It's becoming more popular. Distributional forecasts. People want to be able to bound a distribution around a forecast. Well, I couldn't fit it into the course. I may include a little bit of discussion on it in the deep learning, because some of those, like the GluonTS, the deep AR, provides a distributional forecast. But the key for me is that's not in the 20% that creates the 80% of results. It may be for some people, but with a confidence interval, you can generally, kind of navigate that. And then I can have a learning lab on a more specific topic, like the distributional forecast, if people are specifically interested in that.
Mm-hmm. Okay, great. Let's maybe take two more questions. Speaking of models, do you cover LSTM models in this course?
I cover the LSTM. I have 2 lessons in learning labs on LSTMs from scratch. Yeah. So I'm not doing an LSTM from scratch. It's already covered elsewhere in the ecosystem of business science. Now, what I will say is I cover GluonTS, which uses LSTMs for the deep AR and the deep VAR, which is for multivariate. So yes, I cover LSTMs because they are LSTMs. Now, my goal is to teach you how to be most productive, which isn't to try and necessarily develop an LSTM from scratch, because from a productivity standpoint, these algorithms are going to outperform just a canned LSTM. Mm-hmm. So that's why, like the NBeats, which does the neural basis expansion, that's the RAGE. They ran that against the M4 competition, and they beat the top result by like, I don't know, 20% or something like that. Like it was pretty impressive. So you can build an LSTM from scratch. Do that in Learning Lab 36. I will point you there. And I love that Learning Lab because it teaches you how to actually do it from scratch, which is something I get requests from a lot. But this course is not about necessarily building from scratch. This course is about high performance machine learning and time series analysis. So to get high performance, we have to be productive, and we have to use the tools that are already developed for us that get the best performance.
I think that's well said. Okay, one more. This one's from Mohit. He asks, question, will we learn forecast? Okay, but will we also easily interpret the forecast results obtained from all the models to a layperson? So yeah, this is about communicating why one model is better than the other. And yeah, so not just about accuracy, but also communication.
Yeah, so we don't really cover communication as much in this course. Again, it's something I've kind of covered elsewhere. So like the 201 course, to me, like if you're interested in business consulting, that is the communication course for you, because what you do is not necessarily tie the data science it's important to be able to explain what's going on if you're asked, but what's super critical is to be able to tie a confidence, and also to be able to showcase how much is going to save the organization when you implement the system. So those types of concepts, tying a machine learning algorithm to an ROI, return on investment, that is covered in 201. Simulation is covered in 201, and recommendations. So recommendation systems in 201.
Mm-hmm. Okay, so I said that was the last one, but this is the last one. So does this methodology apply to finance, to a project such as finance, given that there's so many discrepancies in the finance project space?
So it depends, because certain financial data, if you're talking about predicting the stock market, probably you're better off using Tidyquant and not trying to predict the stock market, but to develop a portfolio that's going to manage your risk. Because the problem with predicting the stock market is the most of the variance that ends up hurting you. So your downside risk is related to events that have never happened before. So like COVID, for example, who could have predicted that? It's very difficult because that event has never happened before, and we have never seen anything on the same scale in the past 100 years or so. Mm-hmm. So, but if you're talking about cash flow analysis, like or accounting, when is a particular customer projected to make their payment? Are they consistently making payments? Those types of things. That is easily predictable with data science and machine learning. So yeah, that's something that can very easily be done. So it all depends on what you're asking about in finance. Finance is very broad, but there's a lot of time series analysis that can help finance.
Wonderful. All right, I think we'll wrap it up there. Just threw in the course links for you once more. You can go check those out, see details for each one. And thanks so much for everyone for joining us. I know it's a lot of questions. I think we still have about 40 unanswered questions, but
yeah, well, we could probably stay here for another half hour to try and get through all of those, but I'll be in the Slack channel. So if any of you are my students, feel free to ask me questions. I really appreciate everyone for attending today. This has been something I've been working on for such a long time, and I'm really excited to share it with you. For all those who asked about the cheat sheet, I'm going to send that out to everyone tomorrow. So don't you worry. You're going to get a copy of it. You're going to get a copy of the video. You're going to get everything. So I'm really happy that everyone stuck around, and you know, I really appreciate you for checking this presentation out.
Definitely. Thanks again, everyone. We'll see you on the next one. You guys
All right.
take care.
We'll see you. Bye-bye, guys.
All right. Bye, Matt.